Okay, ladies and gentlemen, here is yet another video I found highlighting rotating space habitats, and it's pretty cool design. It's good artwork. Not really sure which software they use, but it's something that could be done in Blender clearly, and I would have taken quite a lot of time to make something like this in Blender. It looks like a lot of work. But let's check out this 4-minute video. And afterward, we'll have a little bit of discussion, and let's kind of summarize the value of what's good about this design, and listen to what they have to say about it.
Exodus Star provides space habitats in low Earth orbit. This small 268-foot diameter rotating space station will provide 1 g and less of gravity, enabling long-term habitation without the negative effects of living in space. We specialize in providing a habitat for living and working, with areas for manufacturing, research, assembly, and repair. New space-based solar power systems are being funded. Large telescope arrays are being designed, and an increase of military activity is raising the need for permanent habitation in orbit. All these new systems will need servicing, and while robots will be able to accomplish most tasks, having humans in space will be essential, and with SpaceX Starship, it can be profitable. We will provide a home for those workers and scholars to accomplish their goals and research while staying healthy and strong. Exodus Star enters at the start of a new industry in space, and we will initially focus on low-gravity research. We look to provide these environments to give us more knowledge before we attempt long-term habitation on the
Hmm.
Moon or Mars. The other side is the hardware that gets us into space. And now with the advent
Okay, so just a couple notes. I don't want to rewind. I want to stay where I'm at. But before, when it was showing the whole station, you saw that it had been covered with solar arrays. For some reason, the solar arrays are placed at different angles. It's like the front of the station facing the sun has different angles of solar arrays. I don't know what the advantage of that is. Why wouldn't you want to have them all at the ideal angle to capture the light photons? Um, and also just about the rendering of the video. There's the frame. I mean, something about the frame rate is just kind of messed up. maybe a higher frame rate or something. I bet they use like maybe a 12 frames per second, or should be at least 24 or 30. Um, but I've had the same problem too when I've rendered videos with my designs in Blender where it's like stuttery. But that doesn't take away from how much I applaud you for making this whole design, developing your model, uh, animating the camera. I know, it is so much work, so much work. Easily, I bet there's like 1,000 hours or more in this video. So, honest to goodness, I might pick apart the things that need improvement. I'm just mentioning it. I mean, unless it's like Hollywood movie quality, there's going to be something to pick apart. And even if it is Hollywood movie quality, there's something to pick apart. But overall, I'm really loving this, and I think it's a really cool design. Let's continue going, and I'm going to have some more feedback for you.
of a fully reusable rocket, the need for orbital repair and maintenance is going to happen. Having a hangar for docking and removing an engine, then using a machine shop to prepare a part can be the advantage of saving a multi-million-dollar spacecraft, and specifically saving lives. Craft and satellite assembly in space can allow for larger structures and design flexibility. Future Moon and Mars missions can have a muster point to start their expedition. Companies can lease space for their own projects, a depot for fueling and loading oxidizer, expensive tourist destination. Medical companies can safely do research and development. Information processing and backup facilities can provide peace of mind. Large platforms for space and planetary monitoring systems. And finally, Exodus Star can provide space-based security and defenses for NATO countries. Exodus Star Orbital Station will have 34,946 square feet of crop area in the habitat, providing 350 square foot of growing area per person. Although this might not be enough food to fully sustain the crew, it will limit the amount of food needed from Earth. Mid-station.
Wow. Look at this. I mean, as you really get going and start seeing like what's involved in this model, this is extensive. It takes so much work to build something like this. And honestly, how to build it in this round kind of way, like that itself, making everything stick to the floor while it's wrapped around a cylinder, like without having to individually place every single item. I mean, I'm sure you're using arrays and stuff, but I the construction of the model, like you guys, this is cool. Also, the design work is very interesting. It's different from how I would like to design it. Yeah, it shows some similarities to Brian Versteeg's work. Of course, his work is the best. Well, okay, Elysium's the best, then Brian Versteeg. And Brian Versteeg has these kind of like living space in the middle on the main deck. Living space in the middle. You got your tables here. There's walking space, and then there's like a big open atrium above you, I guess. But then there's like plants along the side. I guess that's for gardening. It's not how I would do it because I would put the gardening in sublevels. That doesn't need to be on the main recreation deck. That's just a waste of space. Like you can put it on your sublevels. And then make room for more compelling, interesting stuff in your main living areas, like something that looks more fun. um, you know how like on a cruise ship, you know all the uh places, the kitchens and the like the facilities where they make stuff and engineering kind of facilities and stuff. All that's like below in the lower decks, where the passengers never really need to see it. That's what I'm saying about this design. And also, just a quick note about the people. I mean, I know you probably just downloaded some models from online somewhere. A lot of these people are like a little overdressed, you know what I mean? I'm sure you're going to have like the perfect temperature, probably 68 degrees inside all the time, 68, something like that, 70 maybe, I don't know. Yeah, it seems like 68 is where most people are comfortable. And so, yeah, pretty much everybody can wear t-shirt and shorts all the time. Some people might have long pants, but anyway, again, I really applaud this design and I applaud the 3D modeling work because I recognize from my own experience, and I've spent years making 3D models. This is a lot of work, but here we are already 2/3 of the way through this video. Let's go check out the rest of it.
Areas may be used for growing extra food, as well as having bioreactors to grow edible blue-green algae and seaweed. The total estimated annual revenue of the RSS will be $200 million. The projected operations cost for a 20-man crew is $39,720,000 a year. The cost of launch activities are based on a single Starship placing 150 tons into orbit at a stated $10 million. The polyurethane material consisting of the hull will be over 7.5 million pounds, with the station assembly at around 5 million pounds, totaling over 12.5 million pounds for a combined of 42 launches, equaling $420 million. Station materials alone will be $150 million, Research and development will be around $120 million. Crew transportation, about $120 million, giving a total cost of construction of $810 million. The technology for this station already exists. Starship now makes working in space economically feasible. Please like and subscribe. Thank you.
I absolutely do like this. Really good. Wow. So let's go check out their channel. Let's go check out their channel. Read the business plan. Exit a Star RSS. What year was this made? And who's really calling this a company? Hmm. $200 million revenue, cost of business. God, they really have all these basic, very basic estimates. Now here's what I was talking about, where the solar cells are pointed at different angles, and then you have solar cells on both sides. I don't understand that. Maybe somebody can comment back to me and help me understand why there's solar cells on both sides. Like as if you're gonna turn the thing. Oh, these get more in detail. The solar cells get more detail, but the scale of those solar cells, the scale of the cells is too big. Let's see. What is going on here? Oh, okay, so they didn't use Blender, I don't think. It looks like different software. But man, what a detailed model. What is so much stuff. Louisiana. Star mining at Gmail. Who's the people involved about? Make a difference. There's no people. There's no. We are. This is us. William solve blah 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 blah. This doesn't make any sense to me. Okay, well anyway, still a really cool design. I like it. Let's go back to their website. I mean to their YouTube page. Sorry, and look at what is this? Surfer, Stanford tourist. Wow, they really have a bunch of stuff here. This is all a lot of modeling. Beaming orbital power to the moon. Video about Starbase. Wow. Cleaning up space junk. Man, who did all these animations, bro? This stuff is... It's all done by hand. I don't think any of this is AI. I tell you what, we're gonna watch another. We're gonna watch another video. How many views have they gotten? 14,000 on this one? Well, let's watch it. This looks cool. It's only another 2.5 minutes. Let's check it out. I lost the sound. Where's the sound? Okay, maybe there's no sound? Gotta be. Wait a minute. Everything's working here. Wonder why it's not running. Well, anyway. Cool animation. Look at the camera flying through this thing. What are all these things sticking up? Oh, they're like go fetch your robot kind of things. They run along a rail. Oh wow, this is gigantic. Look at the scale of it. That must be a starship. So those robots are huge. Oh, see, you got some cool things going on here. Look at the different decks along the edges that have all those plants, but very different from how I would do it personally, but still very interesting. I love how the beach it has a beach. That is cool, man. That's cool. Hmm. Can we speed it up a little bit? I guess we're almost all the way done. Let me blow this up. That's amazing. Well, ladies and gentlemen, please do visit. What's it called? Exodus Star. It's a very cool YouTube channel. This particular video has been watched 14,000 times and has 330 likes. You know, for rotating space stations that aren't like a huge channel, that's a really good job. And, you know, I applaud these folks for their efforts. And, yeah, please visit their channel. What do you think about it? Do you have any comments, thoughts? What do you think? Do you like, dislike, agree, disagree with design elements? You know, the general approach overall. That's the cool thing about this whole genre is there's so many there's going to be so many different ways to go about it, and basically, when somebody has the resources, they will go ahead and do something. You know what I mean? They're going to like build a Stanford Taurus with their own resources. I don't think it's going to be Elon Musk. Because even if Elon Musk continues working another 15 years, that 15 years could easily be consumed with just going to Mars and building a Mars habitat. Maybe he works another 20 years. And I don't really think Elon Musk is going to do anything with rotating habitats. He's never talked about that. He's always talked about colonizing Mars. So it's going to be up to some new leaders, some new industrious people to lead the way, to build up their success in industry and use the resources that they gain toward building rotating space habitats. And I can't wait to see it. I think I'm the right age, and any of you folks who might be younger than me are the right age to witness it. And maybe some folks who are older than me. I'm 43. So, yeah, it's an exciting future. All right, so stay tuned next time, and we'll check out some more rotating space habitats and other habitation concepts. Thank you.